Hello everyone. So today is going to be our day 25 of the DSA challenge, and the question that we're going to solve today is a linked list. Okay. So before jumping onto the question, let's first discuss what a linked list is. Okay, and why is it important, right? Great. I will draw something like this. Okay, 1, 2, 3, 4, 5. Right. So 0, 1, 2, 3, 4. Right. So basically, it has five spaces and it's an array, right? I hope you already guessed it. It's an array. Let's just consider it an array of maybe numbers, right? Array of integers, right? See, what I'm trying to tell you right now is language independent. All right, it's language independent. You don't need to worry about if it is in C++ or is it in Java, it is in JavaScript or whatever language that you are, solving the questions in. You just need to understand why we'll use linked list, right? Very basic. I'm not going to go into the depth of it, but yeah, you still need to know. Okay, let's just say this space is maybe somewhere space. This is the memory address. Okay, 1000 is the memory address of this zeroth index of this array. Okay, so somehow, if I somehow know how to, if I somehow know how to print the memory address of a variable basically, then assume array of 0 to be at 1000. Okay, this is something that you have to assume. Okay, great. What will be the memory address of array of 1? If you already know of what array of 0 is, if you already know what array of 0 is at which address, and you already know that this array is of integers. That is why I told you in the beginning that this is an array of integers. What will be the array of 1? People might say that, hey, I don't know, right? I don't know how to print that. But let me tell you something. Arrays are that kind of a data structure which stores memory in a continuous manner. Okay, in a continuous manner. So it cannot be that after 1000 the array one will be at maybe 2000 or 3000 or 4000 or x number. This is for sure. If array of 0 is at 1000, then an integers, I hope you already know that int takes 4 bytes, right? 4 bytes. So from 1000 till 1003 will be storing array of zeros bits, right? That you know, like for example, 32 bits that you know, right? 32 bits. So 0, 0, 0, 0. Let's just say here 1 is stored. So dot, 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 whatever. And at the end, 0, 0, 1, right? This is what will be stored in these three cell blocks, assumed to be it a cell blocks. And this will be stored at 1004 for sure. Sorry, 1004. If I write again, it will be 1004. Okay. Now, if this array is of maybe length, let's just say n is equals to 1000, 100, or maybe 1000, or whatever you want to take. Don't you think this will occupy a lot of space? This will occupy a lot of space. Correct. This will. That is why linked list comes into play. Now, what is a linked list? Okay. See, linked list consists of two things. Two things. Data, a pointer called next. Okay. A, a pointer called next. Okay. Great. What does this data mean? This stores the value. Let's just say if one is stored here, and you say that, hey, let's just say this name, the name of this node linked list is node, right? This is a node basically, right? This is a node. This node consists of two things, a data and a pointer. A data and a pointer. Okay. And if I say that, hey, node dot data, it will be one. Okay. Now what does node of next stores? Great. This pointer, right? This pointer is a pointer that points to the next node. Next node. Now what does this mean? Okay. Let's just say I have one node here, one node here, and one node here. Maybe the address is 1000. Maybe the address is 2001. Maybe the address is 4013. Can you say that this is one array? No, right? Because you know that addresses do not match in a simultaneous manner, in a heterogeneous manner, basically homogeneous manner. Sorry, not heterogeneous. They do not match in a homogeneous manner. They are not growing homogeneously, right? They are growing exponentially. We don't know like what is the relation between them. Okay, let's just say here 5 is stored, here 6 is stored, and here 8 is stored. Now, the question is, hey, I want to run a loop. I want to run a loop such that 5 should be printed first, then 6 should be printed, and then 8 should be printed. I have three nodes with in which 5 is stored, 6 is stored, and 8 is stored as data. And I want to print their datas, but I don't know how to reach them, right? Do you remember there was a pointer? What if this points to this? What if this points to this? Then can I run a data that, hey, this dot next is equals to 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 this, right? This is the benefit of using a linked list. Basically, the node can be stored at any address. So basically, no memory leak will be happening because you know, right, that if you store an array, right, it will take a lot of space. It will take a lot of space in the same thing. Basically, 1000, then 100, then 104, maybe if you are taking for integers, then dot 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 dot, dot plus 4 every time because it takes four spaces, right? It takes four spaces. Great. But if we take a node, a linked list, basically, then we don't need to care about it because I know that how if I'm at 100, sorry, at 1000, I know the next will be stored at 1004, but I don't know if after 1000 which linked list will be stored where. But I have a next state. I have a next pointer which will point to the next, basically, which will point to the node of the next node, basically this one. The node, this pointer will be pointing to this node, right? I can get a reference of it. This is storing a reference. This is storing a reference that, hey, I know where where that node is saved. I know somewhere it is there, and I know where it is. If you want, I can tell you the address. You can go there. I know how to point that. I can point like, see, this is a finger, right? This is pointing to something. Let's just say I point to this left direction. For you, maybe it is coming right because inversion of mirror. So this is left for me, right? I know that, hey, I have something on my left. If you want to know what is that, I can point you to there. I know where to go. Don't worry about it. I know the reference of it. Okay. That this is what it is. Let's just not go into the depth of it. Just know that, hey, memory leakage problem is solved in a linked list, and you don't have to save data in a homogeneous manner. You can save anything anywhere in the address, uh, maybe at any address, and then you can just point to that thing. That's it, right? Come on, let's now come to the main question. Okay, great. Now question says that given a head of a singly linked list. Now what is a singly linked list, doubly linked list? See, singly linked list is something that goes in one direction and not the other direction. So I'll tell you, don't worry about it. Return the reverse linked list. Okay, great. So if we are given 4, 5, and this is at null, 1, 2, 3, 4, 5, right? This is given. This is an input. Our output should be 5, 5, 4, 3, 2, and 1. And 1 should be pointing to null, right? 1 should be pointing to null. Okay. How will it do it? This is your question. Okay. Let's just say I have two nodes only. I have two nodes only. Let me take two nodes. This is one node. This is one node. This is another node. This is 1. This is 2. Right now it is pointing to 2. Okay. Right now it is pointing to 2. And 2 is pointing to null. Okay. What if? What if? What is the thing that I want? I want that, hey, 2 should point to 1. 1 should point to null. And this should not be there anymore. And I can just remove this and say that this should point to null. Basically, there should be no direction of 1 to 2. The direction should only go from 2 to 1, and this should be my new head. This should be my new head. How will I do it? How will I do it? Okay, let's just say this is 1, this is 2, 1, 2. This is my temporary. Okay, I'm not tampering head right now. I know this is my head, but I will not play around with head. I will not play around with head. So don't worry about it. Okay. So we'll just take a temporary. Okay. And let's just say that this is my next, or not even next, not even next. Let's not confuse each other. Let's say this is my front. This is my front. Okay. I want somehow that this front should now point to temp. Front dot next should be equal to what? Should be equal to temp. And this will happen so on. But now if I have pointed this to this, how will I come to this point? Right? You know that, hey, I know that I can come to this point very easily because I can say that, hey, temp, you can be my, you can be equal to front. Okay. Front is equals to front dot next. From here, you can say that, hey, then front. Okay, let's not take front right now. No problem. No problem. But let's just say this has a previous element as well, 0. Okay, this was pointing to this. This was pointing to this. This has to point back to this as well, right? This has to point back to this as well, right? So I can say that, hey, temp dot next can be equal to priv. What if I call it priv, right? Right? Correct. Correct. So basically, I am pointing this to my previous, this front to my temp, and I will move priv to temp, temp to front, right? Let's write down some dummy code, okay? What did I say? Let me say that, hey, let me save some reference for front. I should know what front is, right? It should be temp dot next. What should be my temp, by the way? Is head by right now? Is temp right now? Is head right now? Correct. Okay. What is my priv? Priv is null. Why is it null? Because you know that this front, this is the first index, right? This is the head. This should now point to null. Correct? This should point to null. Okay. That is why I took some previous element as well. Okay. I know that hey, front is saved as temporary.next. Okay. And I should say that hey, temp.next, what you become? You become to equal to previous. Great. Prev is equal to temp now because prev will come to the next pointer and temp should be equal to front. Correct? Correct? Okay. And this should happen how many times? This should happen while while temp is not equal to null. Why did I say that? Okay, let's discuss this as well. Let's discuss this as well. Okay, one, two, three, right? And let's just say this stores one, two, three, four, five. Null. Okay, this is head given. What did I say? I say temp, you come to here. You are equal to head right now. What is prev? Prev is equals to null. Okay. Is temporary null? No, it is not. It has something, right? So I will say that hey, front is equals to temp dot next. What is temp dot next? This is temp dot next. So this becomes front. Correct. Temp dot next. Now this should now temporary should point to previous. This should point to null now. This should point to null now. Fine, great, I did that. Prev is now. So this is deleted. This is now deleted. Prev is equal to temp. So prev from here you come to here and temp becomes front. Temp becomes front. So this is what temp is. Great. Okay. Is temp null? No, it is not. Then this becomes my front. This is my previous. I will say that hey, you go from here, you point to here. Okay. Prev now comes here. Temp now comes here. Front now comes here. Again. Prev, temp, front. Again, this happens. This gets deleted. Again, this temp comes here, front goes out, and prev comes here, right? Isn't this happened? This happened. Now this happened. This thing happened. Okay, temporary dot next is equals to now prev. Then front goes again out somewhere. Temporary now becomes equal to null, and prev now equals to this. 5 is pointing to 4, 4 is pointing to 3, 3 is pointing to 2, is pointing to 1, 1 is pointing to null. Isn't this what we required? Now, what should I return? I should return nothing but prev. Why am I returning prev? Because, because prev is at 5. Prev is at 5. Correct? Correct. This is what needs to happen. This is nothing but O of n time complexity, space complexity. O of 1, we are not using any extra space. I could have done it in extra space as well. As well. I could have taken a stack or maybe an array which should store all the values 1, 2, 3, 4, 5. Correct? And now, so let's just say if 1 is stored here, 2, 3. 4, 5. 1, 2, 3, 4, 5. This is my head. This is my temp. Every time I will reach a node while temp dot next is not equal to null. Because I want to come till here and not till null. Great. This is pointing to this. This is pointing to this. Okay. I will say that, hey, array dot push temp dot data. Great. I will say that, hey, temp is equals to temp dot next. Okay. This now becomes this, and this will happen. Okay. This again becomes to this. 2 is happened now. 3 will pushed. Then T comes here. 4 will be pushed. T comes here. 5 will be pushed. Great. And you know that next is okay. It just should be temp is not equal to null. Okay. Then this should go here, and you will say that, hey, it is equal to null. So break your loop. Again, I will bring my temp to here. Again, I will bring my temp to here. So if I remove this line, again, I bring my temp here. I will say that, hey, temporary, again, while temp is not equal to null, I will say that, hey, temp dot data is nothing but array dot pop, right? What will be popped out? First thing, 5 will be popped out. Okay, great. Then 4 will be popped out. Then 3 will be popped out. 2, then 1. Isn't that what LIFO is? Correct. That is what LIFO is. And then just simply temp is equals to temp dot next. Great. Let's try run this as well. My temp is here right now. This becomes 5 because this will be popped out. So this goes. Then my temp comes here. This becomes 4. Great. This popped out. Temp comes here. 3 is popped out. Then this comes. 2 is popped out. Then T comes here. T comes here. 1 is popped out. So 2, 1. And and this is what we require. 5, 4, 3, 2, 1. Time complexity O of 2n. Space complexity O of n again. This is the naive, and this one which we discussed first was optimal. And this one is not recursive. This is iterative. But there is one more thing that is recursive. I will not discuss recursive right now. I will not discuss right now. You can obviously do it yourself, but I will tell you this. There is one more way. I know how to do it, but I just want you guys to try it out first, right? Think of the way that you need to break bigger problem into smaller problems, smaller problems. This is what you need to return, right? Let's try to run it. I showed the a little much of code of the recursive part. People can pause on the video and they can see. But I would want you guys to try it out. Okay, let's try out the iterative approach. Okay, what we discussed. Okay, I will say that, hey, temp, you become equal to head, and priv, you become equal to null. Okay, you just start from it, and I'll say that, hey, temp, if you're not equal to null, then I should run this loop. What is the first thing that we require? We require a front. What is it? it is nothing but temp.next, correct? Now, I want that here, temp.next, you should point to priv, correct? Now, what do I want? I want my priv to be equal to temp, and my temp should also move forward, which will be equal to front. And what will I return at the end of the day? I will return nothing but priv. Let's try to run this code. Should be accepted. Let's try to submit it. Great, accepted. Right? Very easy question. Also, you will notice that here it is written easy, but you just need to understand those things that, hey, I need three pointers. One is temporary, which will be pointing to head. One is the next phase, and one is the previous node. That's it. Next node and previous node. How will I somehow point my current node to my previous, and how will I move my previous to current and current to next? That's it, right? Uh, let's write some notes. Take three nodes, priv, cur, next, cur points to head, priv points to null, initially, initially, next points to curs next, and then move the pointers accordingly. That's it. Let's save it, close this, mark this as done, right? I hope you understood the approach. I want you to try it out yourself. Do a pen paper thing first. Do a pen paper thing. Linked list can only be solved if you use a pen and paper. That's it. That's the ultimate goal of it. Thank you so much, guys, for joining in. I'll see you tomorrow. Find the middle of linked list very easy. You don't need to worry about it. So the only difficult question I think from this will be merge is also easy. I don't think it should be that difficult. I think this is add two numbers is something that you will need to, focus upon. This is the one that is important. And yeah, we'll reach to it when we reach to it. Thank you guys. Bye bye. I'll see you tomorrow.